In this video, we'll do an example to show how to use U-substitution with a definite integral. So we have this integral from 0 to ln of 2 of the quantity e to the x plus 1 being cubed times e to the x dx. So we can do a U-substitution on this, because if I let u be the whole e to the x plus 1, then du would just be e to the x dx. And now I'm going to be good to start plugging in. But because we have these limits of integration, I want to talk about two methods for handling those. So method one is going to be to change the limits. Okay, because right now, those limits of integration are in terms of x. So one of them is x equals 0. But if I do a u substitution, I switch my variable to be u. So I need to know what this limit of integration is as a u value. Okay, so to get that, I'm going to plug it into the substitution. So u will be equal to e to the 0 plus 1, which is 1 plus 1, which is 2. All right, and with the other value, x equals ln of 2, if we plug that in, we get u equals e to the ln of 2 plus 1, which is 2 plus 1, which is 3. All right, so I want to put a little bubble around this. So when we do our substitution now, we get the integral, and the 0 switches to a 2, the upper limit switches to a 3, and then the function that we're integrating becomes u to the third, and then e to the x dx. That whole thing just became the du. So du. This time I didn't even need to isolate dx. I could clearly see du in here. All right, so let's do this antiderivative. This will be u to the 4 over 4. Then I got to plug in the 3 and the 2. Plugging in 3, we get 3 to the 4th over 4. Minus plugging in 2, we get 2 to the 4th over 4. So this is 81 over 4 minus 16 over 4, which is just 65 over 4. And that's our answer. So I mentioned that I wanted to show one other method for dealing with those limits of integration. So method 2 is going to be to don't change the limits. There's just a way that I have to notate it very carefully if I do it like this. So if we don't change the limits, we would have had our integral of u to the third du after I did my u substitution. So if we kept the values as 0 and ln of 2, I have to indicate that these are in terms of x. Because if I don't, it looks like these are in terms of u. So I have to write that this is x equals 0, and this is x equals ln of 2. And now I can do my antiderivative, which is u to the 4th over 4. And then I have to write, I'm going to plug in x equals 0 and plug in x equals ln of 2. I can't plug these in now because I can only plug these in for x, because these are x values. So now I'm going to sub back in for what u was. And u was e to the x and then plus 1. So we have that to the 4th over 4. And now that we have this back in terms of x, I don't have to write x equals 0 and x equals ln of 2. I get to just write 0 and 2. So notation-wise, when I do u-sub questions in this way, I have to keep writing x equals the stuff until we get to the point where we sub back in for x. Because at this point, the only variable in my function is x. And whoops, I wrote 2 here, but this should have been ln of 2. So at this point, the only variable in here was x. So, and these are x values, so there's no ambiguity by just writing 0 and ln of 2. Okay, so this thought applies for these limits of integration and how I notate them. Okay, so now I'm going to be good to plug in. So we'll get e to the ln of 2 plus 1 to the 4th over 4. And then minus, plug in 0, e to the 0 plus 1 to the 4th over 4. And simplifying this, this will be 2 plus 1, which is 3 to the 4th, and then over 4. And then e to the 0 is 1, so 1 plus 1 is 2. So we get 2 to the 4th over 4. And we already worked that out in method 1. This ends up being 65 over 4. And that's our answer. So in terms of our goals for this section, we finished goal 2. doing a bunch of U-substitution examples. And over the course of those examples, we tried to answer questions like, how do we know to use U-substitution? As well as, how do we recognize what the best choice is for you? That is just something that takes practice. So you definitely want to do a bunch of practice problems to get comfortable recognizing, oh, when do I do U-substitution and when do I not? And what's the best choice for what to let U be equal to?